Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7, Notes 3. So we're going to be talking about combinations, which is similar to permutations, but has a little bit of a different meaning. So let's talk about a basketball league, and it's going to have 5 teams. Let's call those teams A, B, C, D, and E. How many different possible matchups are there? Well, let's take a look at it this way. So Team A can play Team B. And you know what? It doesn't matter if we write Team B, plays Team A. It still means the same thing. So the order in which I write it doesn't really matter because it still means the same thing. Team A can also play Team C, Team A can play Team D, and Team A can play Team E. Likewise, Team B can play Team C, play Team D, play Team E. Team C can play Team D or E, and D and E. So again, if I were to write DE or ED, those really mean the same things. You know, Ohio State plays the Badgers. That really means the same thing as the Badgers playing Ohio State. It doesn't make a difference. The order in which I say them doesn't change the event itself. So that's what a combination is. So let's go ahead and let's take a look at that. So for combination, it's an arrangement or a listing of objects in which order is not important. So when we talked about permutations yesterday, the order was important. We were looking for words like arrange, or line up, or put into some sort of order. Whereas when we're talking about combinations, the order itself does not matter. So here's the formula. It's really similar to the permutations formula with this addition down here. It has an extra factorial on the bottom. So you're still going to put your total factorial on top, and then you're going to put the difference of the 2 factorial on the bottom, and then you're going to put times that other one again. Okay, so that's the formula. So it's going to be calculated out just a little bit differently than we were used to yesterday. So let's go ahead and let's take a look at this first combination here. So we have n choose r. So then on top, I'm going to have 6 factorial. And then on the bottom, I'm going to have 6 minus 2 factorial times 2 factorial. So I had that extra part on the bottom. So this is going to become 6 factorial divided by 4 factorial, 2 factorial. Now yesterday we would look at the factorial and we would say, okay, well that is going to cancel this out to be 6 times 5, right? Because everything from 4 on down is being taken care of. So let's take a look at this with combinations. What I do is I look for the largest permutation on the bottom, and that's 4. 4 is the largest permutation on the bottom. So what I'm going to do just for simplicity's sake to start off with is I'm going to actually write this all out. So on the bottom I have 4 times 3 times 2 times 1 and 2 times 1. Okay, so what I want to do is I want to cancel out the most possible. So what I ended up doing was canceling out the largest factorial on the bottom, which was 4 factorial. So left on top, I have 6 times 5 divided by 2 times 1. So I like to simplify that out. 6 times 5 is 30, and 2 times 1 is 20. 30 divided by 2, or just 20 is 2. 30 divided by 2 is 15. So let's take a look at that in this next one. Let's just really get used to using this formula, okay? So on top we have 8 factorial, and then we have 8 minus 3 factorial times 3 factorial. So then what we're going to do is 8 minus 3 is 5, and then 3. So 5 right here is my larger factorial. So when I look at 8, everything from 5 on down is being taken care of. So we're canceling out 5 times 4 times 3 times 2 times 1. So left on top, I have 8 times 7 times 6. Now if you still need to write it out this way, feel free, but hopefully you're starting to get to the point where you can do some of this in your head. And then on the bottom, we have 3 times 2 times 1. So then 8 times 7 times 6 is going to be 336. And then we're going to multiply 3 times 2 times 1, and that's going to give us 6. So now we can divide those out. 336 divided by 6 is going to give me 56. So that's my answer for number 3. Now let's take a look at a word problem. So there's a group of 7 seniors, 5 juniors, and 4 sophomores that volunteered to be peer tutors. Mr. Picard needs to choose 12 students out of those groups. How many ways can it be chosen? So if we're talking about just choosing a group of students to tutor, it actually doesn't matter the order in which we choose those students, just if the students are chosen or not. So when we're starting, we have 7 plus 5 plus 4. When you add all of those up, there's 16 total students that are being chosen to tutor. But we're only going to choose 12 of them. So let's go ahead and let's set up that combination. So on top, we're going to have 16 factorial, and then 16 minus 12 factorial times 12 factorial. So let's simplify that out. So we have 16 factorial divided by 4 factorial times 12 factorial. So now I see that my larger factorial is that 12 factorial. So everything from 12 on down in this top factorial is going to be simplified out. So what does that leave me on top? That leaves me 16 times 15 times 14 times 13. And everything else is taken care of by that 12 factorial. So that 12 factorial is going away. And left on the bottom, I have 4 times 3 times 2 times 1. So let's go ahead and let's multiply that top out. 16 times 15 times 14 times 13. That gives us 43,680. And then we're going to multiply 4 times 3 times 2 times 1, and you get 24. So you're going to take 43,680 and divide it by 24, and that's going to give you 1,820, and then we're going to write ways. So that's how many different ways you can set up that, or how many different ways Mr. Picard could choose that group of students. Again, it's a word problem, so we want to make sure we label it. Let's take a look at number 5. You and your friends are going to eat lunch. You can only take 2 people with you in your car. How many friends, different ways can you choose friends to ride with you? So we have 6 friends that we are choosing from, but only 2 of them can fit in my car. And first of all, it even says combinations in the word problem, but think about it. Does it matter the order in which I pick students to go in my car? No, it just matters the groups that I pick to go in my car. So combinations a lot of times has this group mentality of just picking a group. So we have 6, choose 2. So then on top we have 6 factorial, and then we have 6 minus 2 factorial times 2 factorial. So that's 6 factorial divided by 4 factorial times 2 factorial. So then 4 is my larger permutation. So when I go up for that 6, everything from 4 on down is going to be taken out. So I just have 6 times 5 that's left on top. And then on the bottom, just 2 times 1. 6 times 5 is 30. 2 times 1 is 2. 30 divided by 2 is 15 ways. So there's 15 different ways that you can choose 2 friends to go with you. All right, let's take a look at number 6. So for number 6, a gym coach selects a team of 4 athletes from 14 athletes to represent a school at a track and field meet. Find the number of teams the coach could make. So if we're just talking about a team, we don't really rank a team, at least not in track necessarily. So we have 14. This is going to be a combination. We have 14, and we're going to choose 4. So then what we're going to do is on top, we're going to have 14 factorial, and then on the bottom, 14 minus 4 factorial times 4 factorial. Well, let's continue to simplify that out. We have 14 factorial divided by 14 minus 4 factorial, which is 10 factorial, times 4 factorial. So 10 is my larger factorial. So everything from 10 on down is going to be taken care of in that 14. So left on top, I have 14 times 13 times 12 times 11. And everything else from 10 on down is taken care of. So I can get rid of that factorial. What's left on the bottom is that 4 factorial. So I have 4 times 3 times 2 times 1. So then let's multiply out the top. 14 times 13 times 12 times 11. That's going to give you 24,024. Up top, 4 times 3 times 2 times 1 is going to give you 24. So then you take and you can divide those out, and you're left with 1,001 different ways or different teams that that coach could make given the amount of athletes that he has. All right, so now we want to talk about how do we know when it's a permutation? How do we know when it's a combination? So we're going to decide which is which. So a subway car has 8 empty seats at a stop. People enter, 5 people enter, and no one gets off. How many ways can 5 people arrange themselves in 8 empty seats? Okay, so here we're talking about an arrangement. Okay, so if we're talking about an arrangement, typically the word arrange is going to imply some sort of order. So that makes this a permutation. So remember that a permutation has a little bit of a different formula. Have your note sheet out for reference if you need to. So we're going to do 9p or 8p5. So on top we're going to have 8 factorial, and on the bottom we're going to have 8 minus 5 factorial. So I have 8 factorial divided by 3 factorial. So everything from 3 on down is going to be taken care of. So left up top I have 8 times 7 times 6 times 5 times 4. So you can go ahead and you can multiply that out. So 8 times 7 times 6 times 5 times 4. So permutations are sometimes easier because you don't have that extra factorial on the bottom. Then you end up getting 6,720 ways. That's how many different ways you can arrange to do those 5 people in the 8 seats on the subway. Remember, arrange typically applies that order matters. Let's take a look at this one. A history test lists 5 names of the presidents, and each person is to choose 2 of them to compare in an essay. Well, if I choose to compare Lincoln and Kennedy, that's the same as me comparing Kennedy and Lincoln. Okay, so the order that I say, it doesn't matter. So that means that order doesn't matter. So it's a combination. So there's 5 presidents, and we're choosing 2 of them. So we're going to start, and we have 5 factorial on top, and then we have 5 minus 2 factorial on the bottom times 2 factorial. So I have 5 factorial divided by 3 factorial, 2 factorial. So 3 is my larger factorial. So everything from 3 on down in this factorial is going away. So I'm just left with 5 times 4. And then I can get rid of that 3 factorial on the bottom. And 2 factorial is just 2 times 1. Well, 5 times 4 is 20, and 2 times 1 is 2. 20 divided by 2 is 10 ways. So there's 10 different ways that you can choose to partner up your presidents if you're given 5 of them. Next, let's go ahead and let's take this. A survey asked people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy watching each sport. How many possible responses are there? Well, first of all, rank. That is another huge word referencing order. Rank represents order, so that means it's a permutation. And we're going to actually use all 5. So there's 5 sports, and we're going to arrange all 5 of them. So let's take a look at how this looks in the permutation formula. So what you're going to do is you're going to get 5 factorial divided by 5 minus 5 factorial. So now you're probably in your head, you're thinking, uh-oh, I have 0 factorial. Well, allow me to provide you with your mind blow of the week. Use it on a first date if the conversation gets a little dry, okay? 0 factorial is equal to 1. I'm going to say that again. 0 factorial is equal to 1. So really, this is just 5 factorial over 1. And 5 factorial is just 5 times 4 times 3 times 2 times 1. So you can go ahead and you can type that into your calculator. And when you do that, you get 120 ways. So there's 120 different ways that you can arrange each of those sports. Next, let's go ahead and let's take a look at number 10. So for number 10, it says there are 20 students in speech club. 3 of these students will be chosen to represent the school at the regional competition. How many different groups? Okay, groups is another way that combinations come off. Okay, so groups is another way to tell you that order doesn't matter. We're just taking a group of people. So we have 20 students, and we're choosing 3 of them. So let's go ahead and let's calculate that out. So we have 20 factorial divided by 20 minus 3 factorial times 3 factorial. So then I get 20 factorial divided by 17 factorial times 3 factorial. So 17 is my largest factorial. So everything from 17 on down in that factorial is taken care of. So that leaves me with 20 times 19 times 18. And then I can get rid of that 17 factorial. So on the bottom, everything that's left is 3 times 2 times 1. So when you go ahead and you multiply out the top, 20 times 19 times 18, that gives you 6,840, and then divided by 6. So you take that and you divide it by 6, and you get 1,140 ways that you could pick teams to represent your school at the tournament. All right, let's take a look at this last one. How many ways can the letters combination be arranged? Well, combination, if we're talking about arranging letters, obviously order matters. Now remember, we had a slightly different formula when we talked about repeating letters. So first thing we needed to do was count how many letters we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 letters. Then we need to divide by letters that are repeating. So I have 1, 2 O's. Since the O's are being repeated, I need to divide by 2 factorial. I have 1, 2 I's, so I need to divide by 2 factorial to account for my repeating I's. And then I have 1, 2 N's, so I need to divide by 2 factorial again to account for the other the repeating of the ends. So what I like to do for these is instead of canceling things out, I just multiply them out. So I went through and I multiplied this whole long crazy factorial out in my calculator. And then 2 factorial times 2 factorial times 2 factorial is really just 2 times 2 times 2. Okay, so when you multiply out the top, you end up getting this right here, 39,916, or 39,916,800, and we're going to take that and we're going to divide it by 8. This is going to be a really big number. So we take and we divide it by 8, and we end up getting 4,989,600 different ways that we can arrange the word combination, and that accounts for all the letters that are repeating. So that concludes your note video today. Go ahead and show me your completed note sheet so you can get your practice sheet. Make sure you take your Schoology quiz.